Welcome to this series of interviews of Cyan with cybersecurity experts. We have with us Volkmar Lotz, Head of SAP Security Research, and with him we will discuss software supply chain security and how the EU legislation helps in this respect. Volkmar, how do you define software supply chain security?
Thank you, Eva, for inviting me to this interview. I'm very happy to be here and to share some thoughts on this, in my point of view, extremely important topic of software supply chain security with you. When trying to define what we are talking about, let's start with what a software supply chain is. And if you have some experience in programming or in software development, you know that you never write all of the code by yourself, but you are relying on certain code contributions from third parties, typically from open source communities. And since this is an iterative process, also those contributors to open source projects are consuming other open source components, you end up with a chain of consumption of software components that then finally end up together with your the code that you write on your own in an integrated and built software artifact. What we see though is that when we assume this way of building software, that entry points and attack vectors not only occur at the code that you write by yourself, but also at those code components that you consume. So when we talk about software supply chain security, we mean all those attack vectors that an attacker can use to inject malicious code in the in software components that you as a software developer are consuming via a downstream use from open source projects.
This sounds very complicated, but why is it eventually important that we understand it and we manage it?
I'm tempted to say it is so important because it is so complicated, as you said. Indeed, what we see is that these dependencies that occur via the consumption of third-party software are increasing and getting more and more complex. Actually, we did some experiments with our own software that we are developing at my company, and we ended up with an average of 900 to almost 1,000 dependencies of for each of the applications that we are using. That means each application which core functionality is provided by our developers has up to 1,000 other components directly or indirectly included. And that increases the attack surface of software significantly. Also, when we look at the way how software is developed these days in industry, or let's start looking back 20 years ago or so. 20 years ago, a software vendor like SAP was owning the vast majority of their code. So you were developing everything from infrastructure components to the actual business functionality. And you were even in our case, when using our own programming language, we even developed our own interpreters and own compilers. And that means the whole software stack, maybe except for the operating system, was owned by us, and we had full control over those. This has significantly changed over the past 20 years with developments like native cloud computing, like agile software methodologies, like continuous integration, continuous deployment, and the like. We are now at the situation where software vendors, commercial software vendors, are focusing on their core functionality. In our case, this means something like the core business functionality, the ERP processes or the human resources functionality that is the core of our offers. Everything else is typically consumed by third-party vendors. That can be commercial vendors, but that can also be open source contributions. And if we think about numbers, even though these are not based on detailed analysis or so, but we can more or less guess that maybe 5 to 10% of the code base is currently developed by us ourselves, and I think we can generalize that to all types of commercial software development. So that means the attack surface is for attacks via the supply chain is increasing significantly over what we have seen, say, 2 decades ago. And it is used. Maybe the first examples of those typical supply chain attacks occurred about in 2017 when there was the Equifax breach, which had a significant impact on their business operations. And we read more and more about those attacks, which means that they are becoming an extremely important attack vector that software vendors need to protect against.
Typically, we discuss in our channel about third-party security risk management, where it's more focused on the business, which are the suppliers you rely on, and what kind of services you use. But here you bring it to yet another level of granularity. What about the software or the elements that you integrate yourself in your own software? As a head of SAP security research, what is your role in this software supply chain security?
So yeah, as I said, my role is in research. So our interest is in providing innovations and new concepts and tools and methodologies that help to manage the risks that occur from those, say, increased risks and threats that I was talking about before. I can just give a few examples of the work that we were doing. For instance, we were developing a tool that allows to analyze across the full chain of indirection, so across the full software supply chain, if there are known vulnerable components integrated in there, and suggesting some mitigation strategies for those risks. In this work, for instance, and that was the research-based innovation that we introduced, we were also moving away from just the information that you could find in vulnerability repositories like CVE, for instance, up to the actual code level. So that allows you to also analyze if the vulnerable components are actually executed in your particular settings in order to prioritize your mitigation activities. So usually when you consume open source components, you rather include full packages, but only use a fraction of the functionality that is offered by those packages. So it's very important to see which of those potentially vulnerable components are even actually used by your application. This tool, for instance, is also open source. It's available at the Eclipse Foundation. Name is Steady. So if you look for Eclipse Steady, you will find this tool. Another example is, because also these supply chain attacks are comparatively new, is to aim at fully understanding which type of attacks can be run and what impact they show and how they can mitigate it. For that, we developed a tool which is called the Risk Explorer for software supply chain, which introduces a taxonomy of the different attack vectors that occur. So currently there are more than 100 attack vectors represented in this tool. It includes also the countermeasures that you can apply on different levels, very specific to a very specific type of attack, or more general to a full class of attacks. And this is all based on references which include scientific literature, but also attack reports. And this tool can be used to raise awareness and to train developers to understand the related risks, but it can also be used as a guidance for analyzing a potential gap between the measures you have implemented and what you would need to protect against the attacks. It can also be used to guide red team activities, for instance, and the like. And the last example I want to mention is that we're also looking into innovative ways on actually implementing mitigating measures. For instance, we are looking into ways on how to debloat code. That means to cut off code pieces that you are not using in your code base, but that you inherit via the consumption of open source components, to make the code smaller without affecting its functionality and therefore reducing the attack surface. So these are all types of contributions. There are even more that I could mention, but I know we want to move on. There are more that I could mention where we as a research team are looking into innovations that help to mitigate software supply chain security risks.
This, as a security expert myself, I testify it's extremely useful and helpful tool to increase the security of our organization, because at the end it gives visibility of the risk profile, but also possibility to limit the risk, especially when unnecessary code is integrated. From your observation, did we learn how to develop software more securely in the last years, especially after the COVID crisis, where we all know that business security become our sector?
You see me smiling because this is a very good question, and it is also a very tricky question. And it's tricky because I think the answer is both yes and no. Of course, activities for secure software development range back 3 decades or so, where disciplines of security engineering and secure code development started. We have learned a lot. We know about typical classes of vulnerabilities for web applications, for instance. We know how to mitigate them. So the theoretical answer is yes, we know a lot about how to securely develop software. But then what we also see is that this is a never-ending story. We see new threats arising. We see new vulnerabilities coming up, and the methodologies that we have developed for the classical threats and risks do not scale to these new ones. Just to give you one example, ChatGPT, I guess we all know how great this tool is only publicly available for 10 months now. And it already has started changing the way how code is developed, because it can not only respond to natural language queries, but also it can generate code. And many developers these days use this as a code. But we also know that code created by ChatGPT can be vulnerable. So we have here a new risk that needs to be covered. So how do our experiences with software development change when, say, an initial version or a code frame or like is not written by developers anymore, but is created by an artificial intelligence tool? So these are new things that are coming up, where we still have to see on how they impact the security posture of code development in general, and how we can mitigate some of the specific threats that arise throughout. So this is why I was saying yes and no. Yeah, we know a lot, and of course we apply best practices in our daily operations, as many other software vendors are doing so as well. But it's not the end. We cannot close this topic because there are new threats coming over and over again. And large language models, ChatGPT, used for code generation is one example. Who knows what the next example will be? I'm pretty sure there will be other examples coming.
Absolutely. This is interesting. In the time we live, it's a continuous evolvement and surprises bringing from technology, but people as well. We discussed the ChatGPT case and AI specifically for cybersecurity and for testing with Rasma Arabi. I invite you to check after our previous video. But you say we don't know what is coming. We have adapted, but we are not scalable yet in the methodology enough. Would EU legislation that we now have and now know about, like the European Network Information Security Directive NIS2, or the Digital Operation Resilience Act for financial sector cyber resilience, change the game, pull the bar even higher in supply chain security, having such a strong focus on this aspect in the regulation?
So I think the good news that comes along with these legislative developments is that topics like software supply chain security are included in the requirements that they pose, and that raises the importance of this topic significantly. And it's necessary to raise those importance, because it is a new comparatively new type of threats. Not all of the software vendors, I'm also thinking now about smaller companies, SMEs, not all of them are aware, not all of them are knowledgeable, and this regulation forces them, as long as they are in the scope of the respective regulation, these regulations, considering software supply chain aspects, is forcing them to think about this problem. That's a good development, because the risk is significant and might not be aware to everybody who should be concerned about this risk. So this is a good development. The challenge with regulations is, in my view, is about the harmonization, because we've seen and I love to see this development. We've seen so many new regulations that touch security aspects coming up in the past 5 years in Europe alone, but also in the rest of the world. And as good as this is, because it raises the importance of security considerations, as good as this is, there's also a risk of, say, fragmentation across those regulations. And this is, in my view, a very important part, is that in this set of regulations, which all have their different scope and their different targets, to maintain harmonization across those, because this is particularly important for us. We are in many sectors, we are in the scope of many of those regulations with the products that we are providing. Excuse me. So we are in the scope of many of those regulations, but we cannot afford, neither we as a company nor our customers can afford, to have separate processes and separate requirements across all of these different vendors. Our goal is, of course, to be able to maintain a single secure development process, a single set of tools, processes, methodologies, requirements that help us to manage the software supply chain security risks, and not being asked to do something different or maybe even incompatible across those different regulations. That's the challenge for the policymakers, I think, to ensure that this harmonization is guaranteed. I also see a good chance that this can happen also, because many of the regulations you were mentioning, the NIS2, which is basically just stating this as an important topic, without giving too many detailed requirements on what exactly that means, and leaves that to either the standardization organization or to the technical community or to the industrial community. And I think this is the right approach, because I'm also pretty sure that over time we will see standards evolving, maybe more industrial de facto standards than standards that are provided by standardization organizations. But I think we will converge on what is best practice and what we need to do in order to secure our software supply chains.
And in that respect, what is the role of the Cybersecurity Act? Yet another legislation that we adopted a few years back at the EU, which sets the possibility and the framework for development of European cybersecurity certification frameworks. What is its role in providing assurance, or helping, or making it more challenging for companies? What is your opinion?
I see certification as a very important element in providing assurance about security properties. And that is, assurance about security properties is actually what customers are demanding. And with certification, you can demonstrate that. It is also reflected in the fact that we currently, in my company, many other companies are doing the same, are working with a number of certifications. I can particularly talk about the cloud. So we are doing, of course, BSI C5 certifications. We have certifications according to the secure operating center standards. We are following the NIST cybersecurity framework and other related standards. And this demonstration against, say, independent expert standards-based frameworks and methodologies is extremely important. And certification is the way on how we can do that. And I can also say that because I'm myself active in this field. I'm a member of the ENISA's ad hoc working group on the cloud cybersecurity certification scheme that is about to come up. And I can see that these proposed certification schemes are addressing many of those very important aspects that you need to cover when you want to securely develop, deliver, and operate cloud services. And it is good to see that, for instance, in the upcoming cloud certification scheme, that there are supply chain related aspects included. So among the, I think it's currently 20 classes of requirements, categories of requirements that are proposed. Among them, there is also an explicit one, which is dealing with third-party software and which includes those supply chain elements. What we need, though, is say, a body of technology contributions that help to meet those requirements that are stated in the standards. And this is, of course, also a challenge for technology providers, for research, and for innovators to provide those methodologies in order to not only state the requirements but also make it easy. We also have to consider that's important to when discussing certification. Certification can never provide a guarantee of security properties. What it can do, though, so that means we should not rely on, this product is being certified, so it is absolutely secure and I can use it without any concerns or additional activities. However, what certification can do is it can provide additional assurance or evidence that the vendor of the product or service that is certified has done their homework and has done their, say, the current best practice security activities in order to ensure that the product is, or the service that they deliver is secure. Now, since we were talking about software supply chain and open source supply chain in particular, I want to add one caveat, and that is the question of how certification can be brought to the open source communities. I see a big challenge there because open source communities are typically based on voluntary contributions by individuals who are not even paid for that, so they do that as their passion in their private time, or sometimes they are employed by companies who have a commitment to support this community, but there is no obligation and no mandatory contribution. And these open source communities typically are, say, since they are voluntarily, they are, say, a kind of community of people who are evaluating that they do not work under constraints like they would do in, say, a company environment where you have all the processes, all the standards you need to follow, all the requirements that you need to follow. And I see a risk that if you want to extend the scope of certification also to those communities, so that means require for certain usages certified components, even if they are from open source, that that many of the people in the community are walking away from the project that they are working on. And that is something we should not risk, because these contributions, as illustrated earlier in the interview, these contributions are extremely important for today's software ecosystem. Yeah, we can talk about an ecosystem because it's not controlled by an individual entity.
Very interesting issue. But do you have a solution? Do you have an idea?
I just wanted to say that I'm afraid I do not really have a solution. And I also recall discussions in the context of the Cyber Resilience Act, where there was also a debate about if open source should be included in the scope of this or not. And I don't think that this discussion has yet led to a solution on how to do that. One thing is to relate, and this is the approach that the Cyber Resilience Act is following. One way is to make the relation to commercial activities. So as soon as there are commercial activities, and we see that not in the creation of open source artifacts, but in the servicing, in the maintenance, also many vendors make a business out of packaging open source solutions and offer them to a customer in an easy to consume way, that those commercial activities are made responsible for security qualities, and also if that is feasible in the case, to provide certified solutions for them. If that is actually something that will work out, it's very hard to say in the beginning. I'm a bit concerned that it would not work out, because this, said, this kind of, say, independent community that is giving themselves their own rules or so is one of the fundamentals of the open source community world.
I understand. So we figured it is a complex issue. You develop tools to increase visibility, also to help companies deal with the code issue. It is even more difficult to certify, especially in the context of open source. But still, we have to provide assurance to companies, organizations, to the economy, society, that we have secure end products. What are companies doing in that respect besides certification, and how does it apply to open source today?
Before coming to that, yes, I'm going to answer to this question, but I wanted to also to make one remark about the certification of this open source. One thing that we can do maybe, and that would work out, is that we do not focus on the software artifacts themselves, but we focus on the way how they are built, on the processes that are applied, and also in particular on the processes that the consumers are implementing in order to ensure that what they consume is secure and that they consume it in a secure way. And this leads to also one element in the whole set of activities that companies use these days to ensure that the software they develop is secure. That is that when it comes to the consumption of third-party software, to have advanced, say, vetting processes or evaluations in place that are exactly also focusing on the processes that that are applied in the respective community, that also look into, for instance, the provenance of the components. One of the characteristics of the open source world is also that components not necessarily come from just a single source, but that they are replicated across for many valid reasons of efficiency and performance in particular. And sometimes when security fixes are made, they apply not to all of the sources where you can find those components. So all of these elements included in a process that ensures consumption is relevant. There's, of course, a downside of this, and that is these processes take time. For instance, in my company, we have such a vetting process, and it can cause some delay in development projects, which might also cause some conflicts of interest, because we all know the software market is a very volatile market, and you have to be fast if you want to position your offers. But you were asking also for the other elements that companies are used, and there is are using to ensure that they are that their software that they release, or the services that they offer via the cloud, that they are secure. And there is typically a whole bunch of different activities. It starts with training and awareness. So I think we have achieved some progress in the past for moving towards a security mindset, where security is not just an afterthought, but it is part of the, say, the DNA of a development organization, and that's very important. We're not at the end of this process, but we have, and that means we need to continue, but this is a very important element. Another important element is that say, to have the responsibility for security, not just in a central organization, but also within the development organizations themselves. For instance, in my company, we are following such a, let's call it a hybrid approach, where there is a central security organization that is mainly responsible for the secure operations of our services and of our infrastructures. But in each development team, we also have security experts that are taking the security role for this development team. And this is advantageous because these roles, they not only have the necessary security expertise, but they also know about the application and the development context, which is particularly important because I think you are aware of a typical situation where developers are confronted with long lists of requirements, not only security requirements, all other types of requirements. And for many of them say, well, I'm not sure if these even apply to what I'm doing here or so. So this type of application context or development context is extremely important. Then, of course, we have processes. So we have, for instance, in our company, a set of security-related so-called product standards, which are imposing requirements for security properties of our developments. And depending on the importance of those requirements, development organizations cannot just say, turn away from them by saying, no, this does not apply or so, but they have to implement those, or they have to find proper justifications, which sometimes go up to the highest level of approval, which means board level of approval, if they are required, if they want to have an exception from those requirements. So these requirements guarantee a number of properties. However, this is a requirement. So we also need to support the development organizations to have all the means in hand that allow them to meet those requirements. So the next thing I want to talk about is tools and mechanisms. And indeed, so we have a whole bunch of tools that both from third-party providers as well as own in-house tools that are part of the development and particularly also of the build and the deployment process that run all types of, say, automated checks on static analysis, dynamic analysis, what is currently state of the art in the security analysis of software. And these produce the reports that are consumed by the development teams, but that are also consumed by central validation teams who have the necessary security expertise. Of course, we have also a whole organization that ensures the secure operations. We are also not only software developers, we are cloud providers and cloud operators. So the operational security is an extremely important thing. And also they are supported by all types of different tools, including artificial intelligence-based tools that help them to maintain the secure status of our operations. And all that is embedded, of course, and here we come back to certification, in a set of, say, standards, frameworks that are not in-house ones, but that are accepted industrial standards, like, for instance, NIST CSF that I had already mentioned, but also certifications like the BSIC5, and then upcoming, of course, the European EUCS, the scheme for cybersecurity cloud service certification.
Great, look forward to the EUCS, and thank you so much for opening and sharing all your knowledge and tools, solutions, but also challenges with us. For our audience, you have playlists, you have also other interviews that touch upon different topics we discussed with Volkmar: vulnerability management, AI, NIS, Directive DORA. Subscribe to our channel to be the first one to learn about new content, but also check our playlist below. Thank you, Volkmar.
Thank you for inviting me. It was a pleasure to talk about software supply chain security with you.